In this video, we're going to look at antibody responses to a primary and then a secondary infection. And antibody responses, of course, follow B cell stimulation. What we're graphing here is antibody concentration on our y-axis relative to time on our x-axis. And what we're going to see is that prior to our initial infection, our primary infection here, we should have no antigen-specific antibody to that foreign antigen, right? Our B cells have never seen it before, and so antibodies have never been made before. Once we are exposed to that foreign antigen, we're going to get our primary infection, and what we're going to have is this significant lag period, a delay. And during that delay, the B cells are binding this foreign antigen. They're probably requiring helper T cell co-stimulation. They have to divide and differentiate to become many, many plasma cells. And then those plasma cells have to gear up to produce our antibodies, right? Our two classes of antibodies shown here are Igm and IgG. The Igm antibody is produced first and is pretty good at complement activation, as well as neutralizing that foreign antigen, binding to it and inhibiting its effects. The IgG class of antibody is better at opsonization, or that labeling function of antibodies. It also neutralizes and activates complement as well. Now, after about a year, what we see is our antibody levels are going to taper off dramatically. Now, they don't fall quite to zero, though, right? And they don't fall to zero because we have what are called long-lived plasma cells that are going to continue to produce antibodies to this foreign antigen for many, many years. Now, this does help with a secondary infection. In other words, there are already going to be antibodies present and able to bind to and initiate an immune response to a secondary infection. However, that's not all that robust because there just aren't that many antibodies. The bigger response in a secondary infection will be the memory B cells, right? The memory B cells produced in that primary infection are sitting around waiting for a secondary infection. Here it is, right here. What we find is a much shorter lag period. Those memory B cells are much more quickly activated. Now what we have is we still get our IgM response, but look what happens to our IgG response. The IgG response is enormous this time. It's much faster this time, meaning we're going to get a much more rapid response and defense against this foreign antigen. In addition to a larger production of antibodies, we get something called affinity maturation. What that means is that the antibodies formed have greater specificity and affinity, they bind to it more readily, that foreign antigen, right? And so they bind to it more readily, labeling it and causing its destruction much more quickly. This graph helps us understand vaccination. Vaccination is the intentional exposure to a foreign antigen, a primary infection, helping us generate this memory response so that when we actually become infected with this particular foreign antigen, a true infection, we have this robust immune response and we are able to wipe it out before it can cause very significant clinical effects.